Today I'd like to talk a little bit about choosing the right motor for your squishy circuit projects. So here we have a typical circuit that you've seen quite a few times now in our videos. A battery pack with two pieces of conductive clay. And we're going to bridge the gap between these two pieces, completing the circuit with a motor. And you'll see that it starts to spin, because that's what a motor does. It takes electrical energy and transforms it, or converts it, into mechanical energy or motion. Here I have a different motor. It's the exact same size, and it looks the same. But if we were to use this motor, it won't spin. So there it is, it's plugged in. We can even give it a little push, because sometimes that'll help start a motor off. But it won't spin. And that's because, even though they look the same, the electrical characteristics and properties for the two are different. So each motor has different ratings, and primarily the two that we're concerned with is the voltage and the current. So the voltage source in our circuits are the batteries, and if you remember, we use 4 AA batteries for our circuits, so that's 6 volts. So this is a motor rated for around 6 volts, and when you buy a motor, you're going to want to look for one around the range of your battery pack, whether that's a 9-volt battery, a 3-volt battery pack, or a 6-volt battery pack like ours. The other, probably more important characteristics we're going to look at is the current rating. Now, what is current? Remember how when this is a completed circuit, just like this, it's easy to think about this as a river, a river flowing and going to and from the battery pack. Okay, but instead of water flowing in this river, we have electrons. And the reason they're flowing is the force behind them is the batteries. They provide the voltage. Now, the actual number of electrons flowing is the current. You can think of this as the amount of water, it's a quantity. Well, we can measure the number of electrons too, and we call that quantity amps. And so every motor has a different rating of how many amps it takes. This motor takes about 30 milliamps. Well, this motor takes many, many, many more than that. I actually do not know the rating because I just found this one in the lab and picked it up. But we special order these motors to ensure that they have a low current rating. So once you know these two facts, that they need a certain current rating and they need a certain voltage, you can find different motors. For example, this one, it's a little smaller. And we can see that if we plug this motor in, it does indeed spin. And so we have a couple of recommended motors that we have listed on our website and that we use. We really do like this one just because it's a little bigger, easier to work with, and it certainly works well. If you find some motors that you like to use, feel free to contact us and let us know which motors those are. Thank you for watching. If you have any questions, as always, please email us or get in contact in some way. Until next time, thank you.